Good evening, everyone, and welcome to day 6 of Intro to Coding Live. Tonight we'll be covering advanced data collections in Python and n-dimensional collections. And I'll explain what that means throughout the lesson here. One second, I need to make a quick note here. Okay. So when we start talking about dimensions, we're effectively talking about nested lists. And when we're talking about dimensions, it's gives the impression that we've got multiple lists inside our list. So we remember how we're dealing with lists. Can anybody help give me a recap of what's going on right here in this code block?
Um, Pretty much creating a list and then you're making it print the uh number one and number five. That should be the outcome.
Yeah, thank you. Um, what we would call this be a regular list, or you could also call this a one-dimensional list. And where that comes from is we just have a single list here. And just like was meant, oh, do remember that we select our kernel each time we start a new lesson. It does change per um, file, but once we've got our kernel set correctly, we have our output, our first element and our last element of our list. And we do remember we can use negative notation to start counting backwards through the list if we wanted to. So as we move into nesting lists, we start talking about what we call multi-dimensional data structures. And when we're talking about a 2D or two-dimensional list, that means our overall list is comprised with a list inside of it. Okay? So there's two levels of this list. We have our outside list right here, which turns into a list of lists. Everybody see that? Any questions here? I know there are 3 lists inside of here, but the way we can look at this is think of it like um, Microsoft Excel or Google Sheets or any other spreadsheet program that you may have used in the past. And we have our rows, and then we have our columns. And generally, I'm not sure how often you guys may have heard it before, but you generally hear people talking about that being referenced as a matrix. So that's why we're using my matrix as the variable number here. Now, when we print this, it prints on a single line. So when we use this white space, it's a very handy technique to help it kind of helps us see the two different lists here. And it makes it so it's kind of easier to just visualize when we just have this small amount of numbers where everything is at. Any questions here?
None.
So I believe yes, we've covered the single bracket indexing, and I believe we've already looked at a list that had a list inside of it before. Sorry, I scrolled that. So when we run these, can anybody give me an idea of what these might print?
Zero.
Sorry for I'm just as an extra clarification. I've got this up here. This is our matrix that we're printing. So go ahead.
Zero is the first one's gonna list one, two, three in brackets. The second one will be four, five, six, and the last will be seven, eight, nine.
And they'll be
That
on top of each other, I'm guessing. I'm just guessing they'll be on top of each other.
Yes, do we remember why?
because that's the way you wanted to print. That's the way we've always done it in the past.
Okay, I know there's a special character that calling these three different print statements gives us. This doesn't have to do with a list. This has to do with us calling three print statements. You're absolutely correct. But the piece that I'm talking about is what it'll do is just like it was mentioned, it'll print the first list. And then because we're calling this a print statement with just our variable, it's going to insert a new line. So that's the character it inserts. So this actually makes it look like our description up here. Now we know that the top example, when we just print the whole thing, Python ignores the white space. So the white space that we use to define our list with our numbers inside of it is ignored, and this is all printed on a single line. So yeah, that's the reasoning why it prints on the individual lines. Any questions there?
And for me,
Okay. I know we covered that special character. Did we cover that yesterday or did we cover that Monday? I believe there was a question regarding how the print was working.
That was last night.
That was last night. That's right. Okay. So by using the single index, we get access to our list. We get access to the first element of the list, which happens to be another list. And you can kind of easily think about this as our first row. That's one of the ways I like to look. I like to think about when I'm coming up with my variable names and stuff like that when I'm referring to a two-dimensional list like this or a matrix. So, given this example up top, can anybody give me an idea what this is going to print out when we add the second index?
It will be so you're asking pretty much to go in the third list, and it will be the second character on the third list. So since it starts from 0, it'll be 0 and then 1. So it should print out that 8, I think.
You're absolutely correct. Thank you very much. And that just prints out just the number, which is the integer that we have here. And that's how we get to our individual elements. Now,
Well, why did it print out the 8? I'm not understanding why it pulled out the 8.
okay. So we'll look at our example up here, and you notice how, you see how for our first index, we're calling.
Oh, okay. Okay. I'm getting that now. Thank you.
Okay, not a problem. Just for explanation for the video's sake, what we're looking at is we're printing the third element, which happens to be the third row, and then we are printing the second element of the list, and that's how we get the 8.
okay.
So we're building on, and that's why this is kind of handy looking at it right here, because this example builds on this example, and you can see the output to get an easy reference right over here. And thank you for that. That was a very good question. Are there any more questions before we move on? Okay. So as we remember, lists in Python are mutable. So not only can we read what the value is, we can change it. So I'm going to pull this over and put our display over here. so that we can reference that for this. Is that helpful, or does anybody need the print statements?
No, I got it.
Okay. So as we walk through this, all this top line is going to do is it's just going to print the matrix. This is the top line is to show what the matrix looks like before we modify it. Now we see which element we're aiming for. So before I hit print on this, which number are we changing to 500 here?
You're changing that 5 on that second list in
All right.
physics.
Yeah.
Yeah,
That's
I did.
1 and 1. Yep.
Yep. Thank you very much. Yes, the 1, which is the second element, and 1, which is, or 1 is the second row, and 1 is the second column. Yeah, sorry. That sometimes I like to explain it that way because it helps make it concrete in my head. And that's one of the most important things when you're looking at these examples and working with things is find a way that it makes it work with your head.
It-
Go ahead.
I'm sorry. Yeah, I was just going to say, you always have to remember that 0. Otherwise, someone will be looking at 1 and 1 going back, and they would put 1, thinking it's the first column of the first thing, and it's not, it's 0.
Yeah, so
Because
that's always a key thing to remember is Python starts at 0. Yes. Um, the other thing is I've worked with spreadsheets a lot, and I'm sure there's a few of you that's done the same thing. So working with spreadsheets kind of helped me think about this because this is like these are your rows, and then in each row it has a cell and that sort of thing. So it kind of matches up in my head. I don't know if that's helpful for any of you guys or not. But as we go through here, just like was said, the 5 turned into a 500. Any questions here?
I'm sorry, real quick, because I can't see. My eyes are bad. Before the 500, that's an equal sign, I'm assuming.
Yes, yes.
Okay.
We use, because it's a list, we can assign the elements. So we don't really, all we're doing is we're telling Python where we want to change the element and we're assigning it to 500. What would happen if I took all of the square brackets out? Like if I took the numbers in the square brackets out, if I did this, what would my matrix print?
Just
500.
500. Yeah, I'm guessing just 500.
Do
Because
we
it's
know
got a new,
why?
because it's got a new command. It'll discount everything else. You're saying my matrix is now 500. That's it.
That's exactly it. And Python is a dynamically typed language. And that's what makes this possible. The difference in some other languages are what you call statically typed, and it would give you a compiler error. But thankfully, we don't have to worry about that here. But yes, that's absolutely correct. Um, Now, I think we were talking about a little bit about using nested for loops with multi-dimensional lists yesterday, correct?
Yep.
So if we go through, we know just like one of the reasons why I was talking about the row variable is we're actually using that term here. So now we know this is our row, and that's where our loop is going first. You can use item, you can use column, anything that helps you remember what you're looking for. But our first for loop is going to just get us to each row. So we need a second for loop because our first row is a list and we need to iterate through that. So on the first pass, when row equals 0, we know that it equals this first list, and then we immediately go into this for loop, this nested for loop, where item will be 0 in our row, and this we can also see that our row is the same variable that we're using. It's the same variable we're using for our current row. And we're checking whatever item is in our current row, and that's how we get to the 0, 1, and 2. I'll go ahead and print that so you can see how, and again, because we're using print and we're just printing the single item variable, there's one variable per line. Any questions there? This might be a little bit difficult to track sometimes because when it's new, but I hope that this is helping kind of break this down.
Yes.
Yeah, I think it is. It's helping out.
All right, cool. Thank you. Clear the arrows, and then we can see we have our list of all of our integers, and we have our 500 right here in the middle. Well, roughly in the middle. Yeah, it's in the middle. Well, aside from two-dimensional lists, we can also have three-dimensional lists. And all we're doing is we're adding another layer. What I'm going to do here is I'm going to copy this over here. And this is always a handy way to help you break out to see exactly what's going on here. I personally choose to do this more times than not because for me, it really helps with readability. And this is, again, one of the reasons why it's nice having that little practice PY file. Just go through here and do some more adding white space. And this is why it's nice to take advantage of the white space that you have because we know that Python is going to ignore it. I'm going to just put that
D,
down there. Yeah, go ahead.
DJ, in simple terms, I got to do it. All you're doing for each one of these matrices that you're doing is you're entering in between the squiggly brackets, which is causing it to break it down.
Yep.
We've seen this.
Right.
That's the basic thing.
Yep, right after the commas. So we
Yeah.
break it out after the commas, but I'm moving the indentation around a little bit to help me be able to see this easier. I like to personally do this, and I highly recommend it. The other thing that we can also note is our different colors in our brackets. Not all IDEs and code editors will color them this way, but it makes it extremely helpful when it gives you the different colors. It helps you see that that's a different list. Is that helpful?
Yes.
And when we're breaking out these line by line, I personally think it's really valuable especially when you're just getting started with multi-dimensional lists. Because quite honestly, I agree. Those three brackets right there is confusing at first to look at. So what we're going to do is we're just going to build off of what we're going to do is we're building off of what we saw with the two-dimensional list, and we've added another dimension. We have our outside list, which contains 3 rows of lists, or 3 lists inside of it. So these are rows. And then inside of each of those, there are 3 more lists. Now, this task right here that we're looking to do from the example is we want to take the row, excuse me, wow, that contains 19, 20, and 21 right here. And we just want to append the text chicken to it. So I described that a little bit wrong. We're looking to append it to I'm going to get this row. At first, I'm sorry. At first, I read it as add it after the number 21. But if we look at how we're referencing here, how many lists are we referencing here? Anybody?
Hmm.
Just two of them.
The
Yes.
yeah.
So what we should be doing here is it should put it right after this one. So if we run it and we go over and we check, no, I was incorrect.
It did it like you said.
It did it like
Actually,
I was said it in the
the
beginning.
first time,
Okay.
yeah.
Yeah.
2 and 0.
Oh, okay. Let me explain why. Because so this is 2, right? This is 2,
0,
and
1, you
then
got it.
this is 0, and we're calling append on 0. That was where I kind of got tripped up, so I apologize. If we wanted to actually change one of these values instead of append, then we would need to add the third list there. So that I apologize for misdirecting you guys there. Does that help clear it up a bit better and where my mistake was?
2,
Yeah.
0, 1, 2. Okay, I got how you got there. 0, 1, 2, and then 1, which is because the 2 and the 1 and the 2, I'm sorry, the 2 and the 0 make sense because 19, 20, 21 looks like 1, but it's actually 0.
So if I
Yeah,
wanted,
and
so if we wanted to put chicken after 19, would I then add a third bracket and it be 0?
um, I,
Or
be- I believe we would have an insert method, I think it was. Let me double check that. Let's double check really quick here. Yes, there's an insert method. So what we would do by using insert, oh, sorry, I referenced a array. Okay, so what we're looking at here is we're looking for element number 1 or index number 1, which that's interesting because that should have inserted after. Oh,
After orange,
it's inserting at the 1 position. So
at the 1.
it's pushing banana to the right. That's what it's doing here.
it
So
becomes the new one.
yes, it becomes the new 1.
All right.
So if we wanted to insert with a 19, we would actually use the same syntax. We would use the insert 1 comma chicken. But in that case, we're still specifying 2 arrays here. And where I was looking is if I wanted to change the actual value, so my 3-dimensional list, and we'll look at 2, 0. But if I want to actually change the value for 19 instead of inserting it, now I need to reference the third one.
And it'll get rid of the 19.
Yes, now I'm replacing it. So when we add the third one, we're looking for 19 itself. And that's where I was getting tripped up a little bit. Does that help
Oh,
clarify things? I can run this
Yeah.
for you guys if you
yeah,
want to see
do
it.
it. Please.
Oh, you know what? It would help if I output it. Okay. Well, that shifts my stuff around a little bit. There we go. And now we see we've changed 19 to 1900. So our inserts and our appends only need to know the location of the list itself because it's a list operation. But because 19 is an integer, we need to reference that integer's location by adding the third bracket. Does that help?
Yeah.
Yes.
Yeah,
Yes.
that's the difference between using the append and inserting or appending a value versus actually changing a value. I think I was oh, lo and behold, that's exactly what we're looking at here, where we get our 24. So I apologize, we stepped ahead a little bit there, but I think everything's still pretty clear, right?
You got it. Yeah. Okay.
All right. So we've got a little bit of a conceptual challenge here. So what they're taking our three-dimensional list, and you can kind of visualize that as a Rubik's Cube. A Rubik's Cube is a three-dimensional item, and it breaks out into a program structure just like this three-dimensional list. Okay. And if we wanted to go through and iterate through that to print each item, you see we need a for loop for each array. Let me clear that up a little bit so I'm not covering up the text. Everybody see that? Any questions here? We can run that, but I've got the text kind of hidden. So what this is calling our layer is, we're calling this our layer. Awesome drawing skills here. So we'll be looping through 3 layers. And then when we get to row, we're looking at this as our row. And then as we saw before, when we went through row and item, each individual integer is our item. Does that help make it kind of visualize it a little bit, or would anybody like to spend more time on this? Any more questions for that? Any questions for this? I apologize.
I do have a question. If you were to take out for the last I guess command like for item in row,
Mm-hmm.
would it then just print out the nine rows and you put
Yes.
a print row in there?
If I can go ahead and comment this out, and then we'll run it. And
All 27s.
What if it was
interesting.
a print row? Would
Oh, you're correct. Yes. Sorry, that was me not changing the variable there. That is correct. There we go. Yes.
Gotcha. Okay, that makes sense.
Yeah, my mistake was I was still referencing this variable that, because we had already run it once, it was assigned to 27. So it wasn't giving me an error, but we didn't update it, and you were correct. We should have used the row variable here. Everybody see how that works? Any questions there? And that is, on that note, that is a good way to kind of manually go through your list and see how your list actually breaks out. So if we take it up one more level and we call it print layer, it's easier. It's better for me if I don't try to modify code that's already there, and then my brain's kind of working with it better. Now, do we see our output here? Shows our two-dimensional list. Then we can go through and add our next loop for row in layer, and then we can print our row. And let me clear this out and run it again. And we see how there we go. Because that's going to get a lot more output. This is doing this because I didn't take out any of the print statements. And this is a good use of putting your print statements in there to be able to see where all the logic's actually breaking out. So our first iteration through the loop, we print our matrix, and then we're printing our list. And then if we get to this result, we already know what that does. Any questions? Comments? This is always a handy trick when you're trying to start building out these more complicated loops and when you're dealing with these more complicated collections and whatnot, so that you can kind of make sure that you're tracking down through the logic and make sure that what you're putting in there and what it's doing is what you actually intend on it doing. Again, we called this print debugging, and it's a good practice to print and run your program often. So as you do things, add your print statements in there so you can get a confirmation of, hey, what is this doing right now? You don't really want to just sit there and code and code and code and code. It may look like that. It may look like it works that way on the movies, but it definitely doesn't work like that in real life. Any questions there? Okay, I'll clear this out. Bring this terminal window down. And okay, so now we have another little challenger exercise here. I'm going to copy this. Does anybody want this code before I delete it?
No, I don't.
Okay. So we have our matrix and we have our print my matrix. And what we want to do between these two is add 200 to middle row. Anybody want to help walk me through how we're going to do this? Oh, and we have this hint right here. This reminder that we have append, extend, and insert to add elements, and we can remove elements using remove, pop, or del. Or del.
You could do, I think, if you put my matrix equals, or my matrix and then the square bracket.
Okay.
And you said the middle row, so it'll be bracket 1. And then another bracket
2.
yeah.
I'm guessing 2. That's my guess.
No system.
No.
Bracket 1 again.
Bracket 1 again? Like this?
I think so, because it's the first list. Oh no, correction. The first one should be 0 because there's only one list. I want to say. Now I'm guessing myself, but yeah. Whatever. We're just gonna go with my matrix.
Do you want to print? Do you want me to print it to see where we are?
Yeah, let's do that.
Okay. So do you want me to print this or just print what the first piece is?
The Yeah, can you print that to see what we get?
The whole thing right here. Okay.
Yes, sir.
This right here is why we want here. I'm going to,
I think it's gonna give you nothing.
there we go.
This is something.
So we do have something right down here.
Okay.
5.
So we would take out the second bracket and then put append
Okay.
and then put 200.
200.
Yeah. Append add 200 to
Okay.
the middle row.
Let me pull this print statement out and then we'll go here. You want me to run it now?
Let's try it.
Okay, so let me clear this out. And are you guys able to see the terminal? I don't know if it's too small or anything like that. I'll run that.
It did it.
There we go. Awesome job. And that helps us with that add that print statement in there. You see how we're able to stop where we are and then start backing our stuff up to see that we've gone a little bit too far or not where we intended to. That's really it's a handy thing to do, and I highly encourage it, especially when you're working on other projects, when you're working through the exercises. It's the key is you really want to see what's going on with the computer because it's not going to tell you, right?
So
And
I did something weird, and I'm not sure why it did this. So my matrix brackets 1 dot append 200 in parentheses, but I put that in a print statement.
mhm.
And when I printed it, just to make it so there's only one line, and when I printed that, it came up with none. Why did that return none and not?
Because the append method returns nothing. And that's why I took that print statement out of there. What it's doing is the append method is modifying our matrix. There's no output really needed because pretty much if you're doing this a lot of times, you don't want it to be printing stuff out to the screen each time. Does that help?
Yeah.
Yeah.
Oh.
It a lot of that just kind of wastes processing time.
DJ, real quick to summarize. It seems like to me you told it to append 200 in the end on the end of 1. And we know that
Mhm.
0 is the top one, 1 is the middle one. So it just defaulted and said, okay, at the end. So that's all you had to put was 1, and it just put it on the end.
Because append is a list operation and it finds our list because we supplied the index. Now,
Okay.
what would happen if I remove the brackets? What would happen if I remove that bracket 1 here?
Which bracket?
That's right. I got too many arrows up. So what would happen if I remove this bracket 1, this index 1? What would happen to my matrix?
Would it add
It
200 to the end of the whole list?
I think it'll just add 200 after the list at one
Yeah.
Yes. Yeah, that's correct. It'll add 200 right here. That's why you can go ahead and play with these things and see what they do because, we're not learning if we're not breaking things, right?
And then I have another question about this. Let me
Sure,
bring
go
this
ahead.
up quick. I apologize if you hear a voice. That's my daughter playing a game next to me.
No problems.
So on the my matrix bracket 1 append to 200, it adds the 200. But if we go up to the previous example of adding or appending chicken, it has my 3 dimension list, bracket 2, bracket 0, dot append chicken, and it adds to that. Why wouldn't that work if I did that to the 200?
because the three-dimensional list has three lists in it, and our matrix has two. Sorry, not three lists. It has
Oh,
three layers
okay.
of lists. I apologize. And that's, you remember when I was going through and adding all the white space in, separating out the brackets out on their own lines? I like to do that myself visually so I can look right at it and see what's going on. So
Okay. Yeah. Right. Because
if
we're
I
working with
went,
just the one list. I'm sorry, I didn't mean to interrupt.
yes, no worries, no worries. I'm going to try because I think this should give me an error. If I went my matrix
Yeah, because I did
and did
the 1 0 and it
one,
gave me the error. I was just trying to figure out why.
one, and then, and you're trying to do it the same way we did here?
Yes,
Yeah,
but you just
like,
explained to me that we're working with one list instead of multiple
yes.
lists.
And it's because we switched lists where that might be, oh, that's actually, I, I know I explained your question, but there was something else. This is what I wanted to do. There we go. And I believe, yes, that should still give us another error because what it's trying to do is it's looking in here and trying to find a list. It's looking for another layer that we don't have. I figured it was going to do that. And this right here, this kind of error in this situation is pretty confusing. So this is where we'd want to stop and try to go through and print each one of the indexes that we're looking at to find out that, if we just tried to print this, it should probably say something like it doesn't exist. Sorry, I'm stepping in a little bit of a different direction, but I hope this is helpful with the.
No,
Okay,
thank you. I'd like trying to
there
see
we
this
go.
too as well.
Yep. So this right here is actually what really tells us it's going on. Is it's saying that the int object is not subscriptable. And what that means is if we trace this down, so we've got row one, we want element one, we've got element one, but this is a subscript which ints do not support. And that's why we're getting a type error here. The first type error we ran into is kind of confusing because it's like, okay, what do they mean here? But as soon as we start printing, what are we trying to modify here? We get a different error that basically tells us we're trying to run an operation on an int that, well, just ints don't support. Sorry for the caveat there, but was that helpful?
Yes, it was. Thank you very much.
Yep, not a problem. All right. Okay, and now I believe we know what this is going to do. Anybody want to take a shot?
Ooh. Would it be adding a new list or an additional list?
Just down at the bottom, it's going to default
Yeah.
again. Yeah, that's it. Another list way at the bottom.
Right down here?
Yeah.
Yes.
Yeah, because we're not calling any subscript, so we're calling it to the whole outer list. And I mean, it'll let you put a number in there, but it kind of messes with your structure. So it's always safer. It's always good to keep in mind what you already have there. So we're adding another list inside of it. And then, just like you guys identified, we added another list with 400, 500, 600. Does anybody have any questions so far? All right, I have 5:56 right now. We're going to take a 10-minute break. Correction, 6:56. And we'll be back at about 7:06. All right, so we just covered appending another list to the end of our matrix, and we see that we've added a fourth list into our my matrix. So now we're going to move into replacing our rows and columns. Now, if we remember correctly, we can use our reverse indexing. Anybody want to remind me what an index of -1 is going to point to right up here?
That
Last
points to
one.
the last one. Yeah.
Last.
And just like we saw when we were assigning other elements, this takes and it replaces our last row with our new row of 10, 11, 12. Any questions there?
No.
All right, and it looks like we've got another for loop in here. So it looks like we've got a lot of stuff going on here. So let's go ahead and start. That was unintentional. There we go. So we're going to go ahead and we're going to take our my matrix, which I need to copy this, put it over here. And we're going to just, ooh, I deleted another block in here. Oh, that does not affect the overall repo. That just affects my particular copy. So in order to get our last row in, that was 10, 11, 12, correct?
Yep.
So now we have our list here. And the reason why I'm doing this is I'm going to go through, and I know when we were covering a lot of these nested functions and stuff, you can start to kind of get a little bit tripped up here. So what we can do is we can start to check to see what each does by taking the pieces out and printing them. So now we know the my matrix is 4. So now we know that if we print 4, that is effectively what we've got here. Now, do we remember seeing this range syntax earlier when we first started covering loops? Do you remember what that does?
Doesn't the 0 start at that first integer, and then the 4 is the what's the term that you used? Inclusive?
And then the mode.
Exclusive.
Exclusive. There you go.
Yeah. So what we can do, what would we use this range to do? What are we trying to do here? So if I go for I in range 4, and I'm going to just print I. What do you think this will give me here?
I'm
Would I get-
assuming the first list, the 1, 2, 3.
Well, so we're breaking away from the list right now. We're breaking down. What I'm doing right here is I'm breaking down this entire thing. So what we've done is we know that the length of my matrix is 4. That's what we got printed here. And when we print, so that 4 goes into the range, and that's what the next thing I printed is. is that's what this turns into, is this turns into range 0, 4. So we're not thinking about matrix. Oh, sorry, I didn't mean to. We're not thinking about matrix right now. We're just thinking about this little block right here. And in this block, we're not mentioning matrix at all. So what else could this be doing?
The numbers 1 through 4, I'm guessing. That's the
Is
only
it
thing I
the
could think
numbers
of.
1 through 4?
Be 0 through 3.
0, yeah.
Yes, that's correct. And that's the key difference when we're talking about that inclusive and exclusive. The exclusive means that in the end, we're going to have 4 results here if we start this at 0. And if we start this at 0, we'll count all the way up until that number. I know exclusive and inclusive can kind of mess with you, and especially if it switches depending on different functions. So I completely get. I mean, it messes me up when I'm changing context between languages and stuff like that. So that's why I'm kind of breaking this down. And now we see that we've got 0, 1, 2, 3. So we know that this I is going to hold one of these values, 0, 1, 2, 3. Does everybody see that? Does that help
Yes.
make? Okay. Now we have this enumerate my matrix I. Now, do you remember what the enumerate did? We'll see if we can print it.
About that.
Now, my matrix I is going to turn into, we're going to just use our first instance just to see what this is going to do. My matrix, and we're going to use our index notation, and we're going to just see what happens. Well, that's not very. So this is giving us an enumerate object. So if we go through, we change our syntax here a little bit. Instead, let's try index, comma, item equals, and then let's print index and print item. Okay, let's go ahead and run this here. The enumerate, what we're trying to do, oh, my matrix 0, this right here. Yes, I definitely goofed up this logic right here. It's trying to, just curious here. Oh. And then we still get an enumerate object. So this one is not so helpful trying to print what this piece is doing here. But what we're doing here, when we know how this range length breaks down. So what we're doing is we're taking the length of my matrix, we're putting it into the range. So this outer loop is going to count 0, 1, 2, 3. We're also taking that index and we're supplying it into my matrix and we're enumerating it. And what that does is it unpacks the index, which is the index number for the enumeration object here. This is getting a little bit.
Yeah.
Yeah. The item is going to be the value inside our matrix. The index is exactly as it sounds. It's the index that we're trying to iterate through. So it's because I'm just going to get this out of my site before I try to debug that. um, it's because we're supplying this with another list that we're pulling out the index of that and then moving into this particular instance, we're looking to find our column here because we're trying to run this for loop, and our end result is trying to change any index of 1. Did everybody see what it did there where I have these arrows? It took whatever the item was. We get the item from the enumerate. So our first time it was 2. If the index equals 1, so we're checking that index in our row, so 0,
I see.
1, and then we're multiplying it by 100. But we're using the I again. So we're using the I for the row. This I is our row because we have 2 lists here to get to the index. The index is the element or the column. And then we end up changing that here. I know there's a lot of arrows here, and I know that was a little bit of a roundabout way to go through things. Does that kind of help clarify what's going on here? Does that kind of make it a little bit muddier? Any comments, questions?
I just
Uh,
had
I'm sorry. Go ahead, ma'am. Go ahead.
a,
Go
I
ahead.
just had a quick question about the second one. So on the second list,
Mm-hmm.
one would be 5, right? So
This 5
five.
right here. Okay, so what I had failed to do when we're looking at this list over here, yes, it would have been 5,
Oh, I see it above. It's
but I
500.
didn't,
Okay.
yes, I didn't pull that right there. So I
Okay.
apologize for that little bit of misleading.
No, no worries. Thank you.
Any other questions?
Yeah, I just need to kind of understand, summarization. You're trying to multiply certain elements of the list by 100, and specifically, so you're using these commands starting with index and a loop in order to go tell Python, look at each one, find the one that we like, and add 100 to it and make a new list. That's the bottom line, right?
Yes, that's where
Okay.
our if statement comes in. Our if
Okay.
statement right here,
Yeah.
this is the only row we want to modify, or the only element we want to
Thing. Yeah.
modify. That's our column right there.
Yeah. So you're telling it to kind of discriminate and only find what we're looking for and then multiply it by 100.
Yes.
And that's just the language to do it. The enumeration is a little a little
The
muddy, but
enumerate the enumeration takes a little bit of practice to play with. When you use enumerate, that's when you want both the index number and the item. So if we just use a regular for loop, all we're going to get is the actual value. But we have no idea we don't know where that is in the list. In this particular example, we're just looking for the middle item of each list to modify. It's a specific case kind of deal. And that's why it gets into a little bit of confusion part. I believe if we go. Yeah, see, the part that doesn't really work well when I was trying to use the enumerate by itself was because I didn't have it nested in the loop in this particular example. So if we enumerate and we go through my matrix, now what we're going to do is we're just going to print, we're going to use an F string here. Index is index, item is item. Let me get these arrows out of your way. Let's clear this up. And I believe this might be all right. Do we see how let me get, okay, so what I'm going to do, I want to make it so we don't lose this. Row I. There we go. There we go. All right, so now we see how we're entering into row 0. And now we see our first time through, our index is 0, and that index comes from this enumerate. Okay. The item is where it's pulling the actual my matrix, and we get the actual value 1. You see that right here? Because this particular instance, we need the index number and we need the item, because we want to multiply the item that matches our criteria here, that is the middle row. So if I go through and I add this if statement, index is 1, equals item times 100. I know I'm adding a lot of statements in here. Okay, and what we're going to do, you know what we'll do? We'll just put a break statement here and spell it correctly. So we just get one iteration of this. I'm going to comment these. Now when we run this, oh, actually that actually works, because if we're looking for our middle, index, once we already found it, there's no reason to go through and check the last one, is there?
No.
You see, so inadvertently, I found a way to actually make it a little more efficient with one more keyword. But you see, by adding these print statements in here, we know where our first pass, we have index, we're in row 0. And then when we hit our index 0, the item is number 1. So we know that's right here. Then we get to index 1, items 2, and then we pass our index criteria where we're looking for the middle index. So that's where I've got my extra print here. I found 2, then we multiplied the item, and then we stepped into the next row. Does it help clarify things? Does it make it a little more confusing? Any questions? I recommend playing with the enumerate stuff just to see what it does. So if we comment all this out and we run it again, it just goes through and tells us where we're going through our list. Is that helpful?
Yes.
Yeah.
Yes.
Yeah, it is.
Yeah.
All right. For this one, we're just doing another. Now this next block here, we're not using the my matrix. This is just counting from 0 to 1000. And then if everybody remember what this operator does? I know we haven't used it much, so
Wouldn't that
this
be the
was,
remainder?
yes, this is,
I can't
Remainder.
this
remember
is
the word
the
for module.
modulo. Yes, that's
There
a
we go.
modulo or modulus operator. Yes. So all we're doing here, bless you,
Thank you.
is we're finding if we're looking for anything modulo 100 equals 0, what we're basically looking for that's anything cleanly divisible by 100. And that's why we get, let me clear these arrows out. That's why we get the counting by 100 starting from 0, because anything times 0 is 0, right? We have a 0 remainder. Any questions there?
That helps with the loops a lot. And you and I discussed you really got to know these loops. They keep on coming up.
Yeah, adding those print statements when it starts to feel a little bit daunting, I'm gonna tell you, and it happens to me too, is these nested loops can get tricky. And
Mm.
that's why it's a little that's why I'm double checking myself, making sure I'm trying to explain this as well as I can, because you can kind of tie yourself up when you're trying to explain how they're going. And that again, that's the nice place where we can start putting in the print statements and say, you know, just exactly where am I right now? Okay. Any questions so far? Okay, I believe we did cover a little bit about nesting stuff inside dictionaries when we were covering dictionaries on day 4. So this might be a little bit of a recap. Um, we have our English French dictionary again here, and we declare it with the key hello with the value bonjour. And then if we remember right, I think we did this on day 4 as well, is we took one of our keys and reassigned it from the string literal into an array of strings. And now now we're taking our dictionary, calling the key hello, and because what I'm going to do is I'm going to add both of these here so that we can see what the difference is. So when I run this again, you see when we just call the key, we get a list. So we know that if we want an individual element from that list, we have to call the index. Any questions there? All right. So for this one's a big dictionary here. So we're going to paste it over here so we can look at it while we're. So we have a little exercise with the school has a data structure that contains all personnel associated with the school, etc. And we have that whole data structure over here on the right. I put it over here so it's easy to reference as we go through the rest of this. If you're excuse me, if you're following along, make sure you click the play button here, or we'll not have that dictionary for the rest of the examples. This print statement here is just to kind of display that you've got it in here. So now we have this next piece that, well, actually, let's have a look here. If we look into our dictionary structure, do we see what we have in these two spots that I've got the arrows pointing at?
They look like sublists or something.
Yeah. Our value here for the class, for the key class, so our key name is class, our value for it is an empty list. And then we have a key called children, and that's got a list in there as well. Everybody see that? And we can scroll down through and you can see where you've got empty lists. There's a list with one element, a bunch of lists with it, and then, excuse me, a class list with four elements. So if we remember when we were talking about using loops with dictionaries, we could use the items method. And do we remember what the items method returned? I can print that here. We could print the school dictionary dot items over here, and we can see.
Does that return the value?
Well, one of our indicators, before I hit play on here, one of our indicators to look for is this right in front. We see we have two variables in here, and we're using a for loop on it, so it's returning to us something. Okay.
Oh, that'd be the key value pair.
Yeah, the key and the values.
Yes. So as I print this over here, our dictionary items returns our key value pairs. So we get a list of key value pairs, which is what I just printed here. And then the for loop knows how to take the first value of it's a key value pair tuple. So it's a list of tuples that it's giving us. And it's important to know because you can index a tuple and the first value, the first element of the tuple is the key. The second element is the value. Everybody see what I'm talking about there?
Yeah.
Yeah.
So if we went through and we just go for key value in school dictionary dot items, and all I do is print key value clear this out, we'll run it, and then we'll get everything. It looks confusing because there's so much other stuff inside here. And it looks like we've got other nested things in here. You see that? Because if we look at our key, you know what I'm going to do here? We are going to, oh, that's a magnifying glass. 1 second here. We'll take a 5-minute break while I figure out what's going on here. All right, I'm going to pause the recording. Okay, so we see that when we loop through our dictionary items, we've got quite a bit going on here. So what we can do is we can add a break statement in here. So what we're going to do is just run this once. So we'll clear this out, run that, and now we just have our result from our first iteration through. So our first item has this key and this value. Now, if we look at that value, we see that there's another dictionary inside of there. Any questions there so far? So what we do with this if statement is we're using V as our value, which we know is a dictionary. And if I take my cursor and highlight over it, you can see that you see variable in parentheses, the V, the colon, and it shows a dictionary with a string comma any. So the string part shows that the keys are strings inside here. And what we're specifically looking for is we're looking for this children key of the sub dictionary. So this particular instance, this dictionary's key name, the outer dictionary has a key called person 56566, which the value for that person is another dictionary. And it has a key inside of it, children, with a list. Any questions there?
So basically, we got as a dictionary inside of a dictionary inside of a, and with a list inside of that. Bottom line.
Yes.
All
That's
right.
where this is becoming a complex data structure. But this kind of resembles actual personnel records. This looks like this might be the way some of your data might get, or some of your data might be organized depending on what you're doing here. And for this, I'm going to scoot this over a bit so we can see what's going on here. Wow, there's quite a bit. So what we're doing is we're checking the second dictionary for the key children, and we want to know if there are any elements inside that children list. And that's where we're using the length or len function wrapping around our dictionary and our children key, which we know over here is a list. If it's greater than 0, we're going to take the first name and the last name of the parent so they can assign it as a key to their new dictionary. So we're going to create a new dictionary here. So we take the parent, for the parent name, this is an F string here. We're taking the school dictionary, which is the large one we're looking at, taking the key, which we got from, we got from the outer loop. The key refers to this piece right here. So we're going to take the person ID, and then we want the first name key, the first name sub key, or this first name key of that dictionary that belongs to that person ID. Was that a good explanation? Do we see how this first piece is working here?
Yes.
And for this, and all we do is we use the same logic and just get the last name. Now we're using an F string or an interpolated string and adding a space in here, so it's got kind of that pretty formatting to have the first name space last name. Everybody tracking what's going on so far? I know there's a lot going on here, so please stop me if I'm going too fast.
Yeah.
So the next step we're going to do is assign the key with an empty value. So they're inside the if statement. They have this names. We have our names dictionary up here. And we are taking the parent name, which is what we just created right here. So our parent name is going to be the first name space last name. And we're taking and we're adding that as a new key to our names dictionary with an empty list as the value. Everybody see that?
Mm-hmm.
Yeah, got the empty list as a value.
So now we have whatever this parent name is, an empty list, and then we start going through. We start going through our school dictionary again. And what we have here is for child in school dictionary. We're using the key that we got from the outer dictionary, which gives us this person name. And what we're looking for is this children array or list. So in order to iterate through that, that's why we're using another list here. And what we're doing is we take our new key we created in our names dictionary, and because that's a list, we can append. And what we see that we're doing here is we're taking our child from our school dictionary, and we're doing the same thing we did with the parent's name. Taking the first name space last name, that's going inside the list that we added to names. All right. So when we run this, we just get we just get two elements of our new names dictionary. And we have our first element with our list here, and then we have our second one here. I'll move my cursor away. Does everybody see what's going on here now? I know there's a lot of logic going on here. If we go through, and what we're looking for is we're looking for anybody that has children. So if we look at our reference dictionary here, we know that this person key has children, and inside that person key, it's a list of other person keys. So when we look at Jim Smith here, we see the first element, Jimmy Smith. If we look at this key, person 94523, that is right here, and that's how we get Jimmy Smith. Everybody see that?
Yeah.
The keys that we're using to signify whether or not it doesn't matter if it's a child or not, every person has a person ID, but some person IDs contain other person IDs as children. And I do get it. It does kind of this is more like database related stuff. So seeing it here in a dictionary can be kind of confusing, and it can be extra confusing if you've never dealt with databases before. So any questions, go ahead. There are no bad questions with this one.
Well, I'll start out with something really basic just to make sure. I've always get a little confused when I see that equals empty set. I'll just start out there. The rest of the logic I'll have to look at, but that empty set always kind of makes me.
So
Why do you have that?
Right here where it has the names?
Yes.
Okay. So our intended result which is down here where we have our parent name, right?
Yes. Yeah. Huh?
If we if we have a parent, we want them to have a list. We know that a parent can have more than one child. So the best way to keep track of that is to put it in a list, right?
Yes.
So we start with an empty list. We start by creating the key and giving it an empty list. And what that does is that gives us access to the append method. If we don't have a list in there, we can't call append. Remember when I was trying to call the index number on an integer?
Yes.
So we started out with an empty list, and then that gives us access to all of the things we can do to a list. It makes it much easier than trying to figure out, where are we going to put this? Because
Okay.
right up top here, this piece of logic up here, and I know I've got a lot of arrows going on here. I apologize for that. But this piece of logic up here tells us that this person has children.
Greater than zero. It's telling you
Yes.
there is something out there,
Yeah,
definitely
there's
with
there's
children.
something in children. So we're adding them to our parents' dictionary because this names is effectively our parents. And then our empty list turns into our list of children.
So you're just telling Python, whatever you find, stick it here as far as a parent name goes, right?
Yes, yes. We want
Okay.
and the extra logic is in here because for some reason our particular use case, we want both the first name and the last name in here.
Yeah.
There is a lot of logic and I highly encourage taking it and playing with it. Take pieces out and see what it does. Um, there is another list inside there that if you want to take it upon your own, you might be able to try to modify this to see if you can get classes. Because now you won't have, well, this is interesting because the classes have, excuse me, person IDs. Oh, that's because it's a school dictionary. So this might actually be a teacher. So you could modify this to try to get the teacher in a dictionary and pull out the person names for the people in their class. It's reversing the it's reversing the logic a little bit, but there's not a ton of things that need to change here. You guys want to see that?
Go ahead. Yep.
So all we need to do is we take children and we change it to class. And we change this to class. Now when we run it, we have an error. Ah, now I remember this from last session. We have a key error because one of the person IDs does not exist inside of our class. So we have this ID right here, but there is no actual person assigned to that. So what we can do to quickly correct that is just take it out. And now when we run this again, oh, I have to, when you change that, keep in mind you have to run this again. So now this class is updated, and now it looks like there's more than one person that doesn't exist. So now we have 67234. This person doesn't exist either. And I bet you there is no 9411. That's 9523. We're just going to change that really quick. Is that 523? We'll run this. And then we'll run this. And now, you see how we changed that to the class?
Yeah.
Yep.
The only problem is some of our class members didn't exist. You could take either the option of just removing them from that particular list or change the number to somebody else who's in the list. Any questions there? I know that was a little bit of a side quest there, and there's a lot of logic in here. I do understand that. Tracing through it does take a little bit of time. And feel free to play with it. See what other things you can do with it. We have our next. This looks like just a repeat of what we've already done, correct? Yeah.
Yeah, like peeling back the layers.
Yep. This is just peeling back the layers and oh, this is a jagged array. This is a jagged list. Now, why I call this a jagged list? Let me add some space here. You know, if you notice, the first list has 3 rows inside of it, and
Mhm.
the other two lists have just 2. Excuse me. A jagged list is when it's not like when it doesn't make basically a square. Does that help clarify why I call this a jagged list here?
Yep.
But iterating through it is just the same way we've done with anything else. Any questions there?
Yeah, do the space I'm sorry. Do the spaces between those make a difference?
No, that's just white space.
Oh, okay.
Yeah. That's why I highly encourage doing it. So then you can just kind of break it out and have it. I
I was
always like
referring to the
lining
spaces
them up.
between like because there's spaces between 10, 11, 12, 13, 14, 15, but between 1, 2, and 3 there aren't any.
See, it still seems the same, follows the same rule as white space.
Okay.
The interpreter will ignore it as long as you're not doing this, as long as you're not taking 1 space 1, then it'll complain.
Okay.
Yeah, a lot of times when you're really breaking this stuff down, it is handy to just add white space so you can actually see everything that's going on, organize it how in a way that makes sense to you so you can see the shape of the data there. Is that helpful?
Yes.
All right. Are there any questions from today's lesson? I know we have our coding examples. We have um some more exercises and stuff to be able to practice working with some of these more complicated data structures. So do we have any questions regarding any of the stuff we covered today, or even if you were trying some of the exercises from the previous day and have a question you'd like to ask, go ahead. All right. So as with the other lessons, we have our exercises here, and these ones are kind of segmented. They have our descriptions. So you have your seating chart here, and you want to update a reserved seat. So you're looking to assign an element somewhere inside there. This looks like it's got all the answers. Yes, it does. Well, I would try to do these yourselves, even though it looks like I'm going to make a note that all of the code is already stored in here. This is we do have our exercises. Go ahead and try these or try to change what they're trying to modify to try to provide a different result. 'Cause this kind of practice is this is really good practice, especially with working with some of these more complicated data structures and whatnot. And we have a little summary of the practical applications of how we're working with these kind of data structures. So with like two-dimensional lists, you can actually implement a tic-tac-toe game that way. Um, there are, we were talking about like how that works in related to spreadsheets. So you can kind of work with data similar to how you have it organized in a spreadsheet. Um, your three-dimensional structures are a lot more are a bit more complicated, but as it shows here, there's geospatial data science and machine learning applications. Um, we can dive into those, but at this point, that's not really the kind of data we're really playing with, but at least getting the idea of how to utilize those is the point of what we're talking about today. And when we talk about n-dimensional data structures, you can continue adding layers to these lists. And believe me, if you add more layers, it does add more complexity because we can imagine you need more for loops, you need more iterations depending on what you're doing there. We have a couple of libraries here. I know we haven't talked much about libraries, but there's some notes about different libraries for working specifically with um, these kind of with like more advanced cases. Now, what libraries are is it's collections of methods and classes that someone else has built is basically like a specialized toolbox. So this pandas library, it's got a whole bunch of tools that are specifically tailored for working with data sets. I know we haven't covered being able to utilize those. We'll touch a little bit on that on next week's mini projects because we're gonna end up importing a library in there. Excuse me. Any questions on any of that? Oh, I apologize. Okay, so these right here, this is titled practice. We can run through these and we'll see that we're adding, let's see here, we're creating a reservation. So we want to change this F to an X. But we did kind of already cover that. So I believe this should have been more along the lines of practice for you to try to implement. But what I would say is go through and see about try to reserve another seat. For this one, adding rows and columns, we we already saw that when we were working with our append, and this has gone ahead and added our Charlie row in here. We see that at the end. And this is another example of going through and appending a row or a column, I apologize. So for the first, when it's looking for our title column or our title row, we added April here, or this example adds April here. And what it does is it tracks through the logic to find wherever April lines up with the rest of the matrix and set all the values to 0. So I encourage you to go through, play with those, try to change the behavior. I believe they should have been set more as practice given the heading. I've made myself a note to check that out. Now, we do have the exercises, which you do have the opportunity to go ahead and write your code for. And I encourage you to use the practice py file so you can build out your code, run your print statements and that sort of thing to just be able to like get practice using the stuff we've learned. And by all means, don't expect to have memorized it just by one day. Be sure to go back through, review things. You have all of the examples on how everything was implemented here. I don't think any of these get as complicated as that nested dictionary one, though. Oh, well, this one isn't as deep, so this one should hopefully be manageable. But if anybody has any issues with this, go ahead and DM me on Slack, and I can help work with these a little bit better. All right. Any questions?
DJ, real quick, kind of an offline question for some of the other work I've been doing. How would we annotate greater to or equal to for a number if you're trying to say that, like greater than or equal to 90? Because there's not a key on the board for that on my computer for that.
Okay. So we kind of touched on that. We kind of touched on that in, I believe it was Boolean statements. So if you're
Yes.
looking at if 5 is greater, okay, so how about we go first equals 10, second. Yes, that is correct, Darwis. I'm going to demonstrate that. 9, and we go if 5 or if first is greater than or equal to second. All right, do you see how we're using both the greater than and the equal sign here?
Yes.
So that's how that's done, because I know in traditional math that usually has the greater than sign with a line underneath it, and that's what you were probably looking for, right?
Yeah, you just put them next to each other then, right? Pretty
Yes,
much.
yes, and
All right.
make sure there's no space between them. Okay?
Okay. That solves some problems. All right. Thank you very much, sir. Thank
Yep,
you.
not a problem. Are there any other questions? All right. I hope everybody learned something tonight. And again, if you need any help, exercises, questions from anything all the way up until this point, be sure to message me on Slack. And I will see you guys on Monday when we start our first mini project. Yeah, I hope you guys have a great night and a great weekend.
You too. Thank you. Good class. Thank you.
Thank you.
Thank
Have a
you.
Good night. Thank you.